Dear students, grade 12. Today's lesson is the second part of our lesson about equilibria. Okay, the learning outcomes in this video, we're talking about how to work the values of Ka and Kb for weak acids and bases, weak bases respectively, calculate the concentration of hydrogen, the hydroxyl of strong and weak acids or strong bases and weak bases. Calculate the values of pH for strong acids, weak acids, strong bases, and weak bases. How to work the value of pKa. Okay, so in this video, we'll study the first three objectives. Okay, just as a reminder, in the previous video, we've learned about the equation of ionization of water, and also we learned that water actually is considered amphoteric. Amphoteric means it can react as acid, also can react as base. We have learned also in the previous video how to calculate the Ka, which is the constant dissociation of weak acids, and Kb, which is the constant dissociation for weak bases. So let's remember these equations. Kw, which is the constant dissociation of water, equals the concentration of hydrogen times the concentration of OH. pH equal, this is, instead of that, this is minus, supposed to be minus. Okay, so this is minus log. Okay, so pH equal minus, equal minus log the concentration of hydrogen. And also you have to remember that both concentration of hydrogen and hydroxyl actually is constant, which is equal to 10 power of minus 14. Okay, this is one example. How to calculate, look at the first example here. These are two examples actually. Calculate the pH of solution whose hydrogen ion concentration is 5.32 times 10 power of minus 9. Actually, this is a direct question. So he's asking the pH. He wants the pH. Okay, this is unknown. And he's giving you the concentration of hydrogen, which is 5.32 times 10 power of minus 4. So all you have to do to calculate the pH is just find minus log the concentration of hydrogen. Okay, and here you have your result. Now calculate the hydrogen ion concentration of pH, a solution which is pH is 10. Okay, this is reversed. So you have the pH, okay, equals 10.5, and you need the concentration of hydrogen. So in this case, the concentration of hydrogen equals 10, so minus 10, 10 to minus pH. So it will be the concentration of hydrogen, once again, equal 10 minus of 10.5, and there you have your concentration. Okay, these are easy examples. Now let's go back to Kw. Actually, it's the ionic product of water. Water molecules can function as acids, as can base. This we have covered before. Kw equal concentration of hydrogen times the concentration of hydroxide, and it's equal 10 to the power of minus 14. Mole square, diameter minus 6 at RTP. So what is RTP? Actually, this is standard conditions. Remember? Room temperature and pressure. So little water is ionized. Why we do not write water? Okay, do you remember the equation? Ka equal H2O. not H2O, the products, it's supposed to be the products over the reactants, right? So, okay, let's write it correctly. Okay, so the products, this is the products, hydrogen, OH, this we applied before, okay, but this is as a reminder, over the reactants, which is H2O. But when we write it to Kw, it becomes just the hydrogen multiply concentration of hydroxide. Where did the water go? Actually, the concentration of water remains almost constant. That's why it's secluded from the equation. Okay, it does not appear in the equation. So, how to calculate the pH of strong acid? Okay, these are the steps actually, so take note. Okay, if you have a base, a strong base, okay, which is XOH. Actually, when it's mixed with water, it completely ionizes into positive ions, which is X positive, and hydroxyl, which is O negative. Okay? So in this case, the concentration of the base is equal to the concentration of the OH. Remember, because it's strong, completely ionized. Okay, remember that. Strong base is completely ionized, so the concentration of the base when it's mixed with water is equal the concentration of the OH. So, let's apply. Kw equal to concentration of H and hydroxyl. So, the H equal, this is the concentration of the hydrogen if we want to know the pH of that strong base. Okay, equals the Kw divided by the concentration of OH. And from that, we can determine the pH. Now, just remember this. The pH actually is from 1 to 14, remember? So if the pH is more than 7, it's basic. If it's less than 7, okay, if it's more than 7, it's base. If the pH is less than 7, it's acid. And that depends on one thing. Okay, let's remember. Okay, here's 1, 2, 3, 4, 5, 6, and 7, 8, 9, 10, 11, 12, 13, okay, 14. Okay, this is the pH, remember? You've studied that before when you were young. Okay, this is the pH. Okay, from that way, acidity increase, and if you're going that way, basicity increase. So if you're going from 7 to 1, acidity increase. If you're going towards 14, basicity increase. Okay, so we got that clear. Okay, next. How do you calculate the pH for a strong acid? Okay, that's easy because strong acid, same thing, it completely ionizes, like the strong base, completely ionizes in water. So the concentration of the acid is equal to concentration of hydrogen. Simple as that. And then you can determine the pH. Okay? Okay, so that was how to calculate the pH for a strong base, a strong acid, which is actually very easy. Okay, because they completely ionize. But what if if it's a weak acid? Okay, let's take it step by step. In a weak acid, we know it's partially ionizes. Okay, so if we have a weak acid, HA, and it's mixed with water, so it's partially ionizes into hydrogen and A minus, which is the negative ion. Okay, now we write the Ka, the expression. Of course, the products, the concentration of the products divided by the concentration of reactants. Check. Okay, let's assume now that the concentration of hydrogen is also equal to the concentration of A, which is the negative ion. Okay, so we can assume that the concentration of the positive ion, which is hydrogen, because it's acid, is equal to the negative ion. So by substituting in that, so Ka equal concentration of hydrogen to the power of 2 divided by Ha. So let's rearrange, we want that. So hydrogen actually equal Ka times the Ha. And if we want just the concentration of hydrogen, we have to take the square root. Now you have the concentration of hydrogen. How easy is it just to determine the pH? Just minus log. Write the equation that can be used to calculate the concentration of proton from pH. Okay, this we have wrote in the first two examples. If you have the pH and you want the concentration, you just have to write 10 to the power of minus pH. Okay, now let's apply some examples to the rules that we have learned. Find the pH of 1 times 10 power of minus 9 molar, molar means concentration, solution of hydrochloric acid, HCl. Remember the previous video was talked about the ICT table? Okay, this is the ICT table. I think it's easy, but you can use whatever method you need. So I use that table, the ICT table. In the ICT table, you have the initial concentration and you have the change in equilibrium. But be careful, here we have hydrochloric acid, and hydrochloric acid is actually a strong acid. So which way we're going to use? Yes, we're going to use the first way. Just define the pH for that. So in this case, the initial concentration of the acid before adding it to water and completely ionizes 1 times 10 power of minus 7. The concentration of hydrogen and chlorine ions are 0. Then as the reaction goes on, or the ionization, actually the HCl concentration is decreased by an X. And it's the same amount that the hydrogen and chlorine increases by X. When it reaches equilibrium, the HCl, because it's very strong acid, it completely ionizes into, and there is no HCl, completely ionizes into hydrogen and chlorine ions. So the concentration at equilibrium for hydrogen is 1 times 10 power of minus 7. Okay, see, HCl is a strong acid. This means that it completely ionizes. Now let's apply that. Kw equal H times OH, correct? Okay, so the hydrogen, because it's added in water, it completely ionizes in H2O. So if you have hydrogen from two sources, the acid and water. Okay, for the acid plus water times the OH equal 1 times power of minus 14. Okay, so I don't know how much is the water, but I know the acid, which is 1 times 10 power of minus 9 plus minus 7, sorry, plus X, which is the hydrogen from water. Times X, which is the OH. Okay, so this is actually a quadratic equation. Actually, it can be solved by that rule. Remember that rule you studied in grade 11 in math, I think. So by applying to that, this is the x square, this is the x, so this is our A, B, and C. Apply it to this and you have your pH. This is our lesson for today. Hope you're fine and see you soon.